Afternoon and welcome to Better by Design using AI tools to backward design and improve your academic program. I'm Dr. Dana Osherwitz and I'm the Associate Provost of Institutional Planning and Effectiveness. We're going to pause a minute and let people in the room. Okay, so in this session, we're going to demonstrate and a little bit practice using AI tools such as ChatGPT and SteppingBlocks to and the principles of backward design to refine and rebuild and regenerate academic programs. And so by the end of the session, I think I'm supposed to stand over here, you'll be able to apply principles of backward design to academic programs. You'll be able to use AI tools such as ChatGPT and SteppingBlocks to generate meaningful program level student learning outcomes. And you'll be able to combine AI tools with backward design to create thoughtful, well-structured, meaningful academic programs. That's what we're going for. Okay, so we're going to have a little warm-up activity. We have a small group. I guess you can make one small group. And you may have different perspectives and experience with this, but I want you to talk about when was the last time you evaluated an academic program, let's say, and what caused you to do that, to evaluate the structure of the program, and what changes did you make and why? And so I'm going to give you 5 minutes to talk about it. You guys can project from things you've seen, and then we'll hear your thoughts about this. So, good discussion here that I'm going to tap into because we heard different reasons, like programs were redesigned to attract more majors, to make the major more appealing, or to reinforce the learning that is going on. And then we heard at the end a reason, which is to think about how the students actually apply the learning once they leave the university, marketability. And so I'm going to add an anecdote to the one we said, which is we redesigned the BA in French probably 12 years ago. And the reason we did it was we recognized we had a degree that was designed for realities that no longer existed. It assumed that students were in that program because they were going to go and get a PhD in French literature. And literally none of our students were doing that. They were mostly business majors that were double majoring in language. And so we thought, well, what are they doing with this major? What is it that it's giving them? What are they using when they leave? And we use that to figure out what the key skills should be and then backward design from there. And so that is the model that we're going to talk about today, which is how do you determine what the core competencies are that your students need once they move out of your program, and how do you use that to create outcomes and design your program backward from there. So this is a great discussion. And I forgot to put the timer bar on. Okay, so don't put it in there if you're not going to remember to click it. Anyway, so what is backward design? We have a knowledgeable group in the room and they know, but for people who don't know, backward design is an approach to curriculum design that begins with the end goal, which is what we were just talking about, or the desired results. And then it works backward to develop learning outcomes from that, assessments or evidence that students have met the outcomes from that, and then works backwards to map the learning that leads to that level of mastery that's being assessed in the curriculum. So it's designing starting at the end and working backwards, which is why it's backward design. And so as we just said, the first step in designing a program backwards is to figure out what your program learning outcomes are. What is the core knowledge or set of skills and competencies that you believe your graduates should have at the end of the program? And those can be aligned with your institutional mission and or industry standards and or accreditation requirements and or licensure requirements if you're in a field where that is relevant. But it's figuring out what are those end needs and then building back from there. And then the second thing, as we said, you develop, once you say, well, these are our core competencies, you say, well, how would we get the evidence to demonstrate that the students have those competencies? you develop the assessment measures, and assessment measures will vary in terms of what's appropriate to the outcome, but it could be capstone projects or exams or written research papers or artworks, depending on what your program is. And then from there, you design your curriculum to lead to that level of mastery that you're seeking. And you find places where the core concepts are introduced, you build them in, where they're reinforced, and then where they're mastered over the life of the program. So that's the kind of model we're working with here. And so now we have another small group activity. And this is the hypothetical program we're going to work with the rest of the session. We're going to think about a Bachelor of Science in Chemistry. And I picked this because I know absolutely nothing about chemistry. So I'm going to show you what ChatGPT can do, and you'll know that I didn't do any of this stuff because I don't know anything about chemistry. So how would you, if you wanted to backward design a Bachelor of Science in Chemistry, and I'm not asking you to come up with outcomes, but how would you go about determining what those core competencies would be for that program? How would you figure out what skills students should have? And then I'll ask you just to maybe take a guess at what might be some core competencies for those students. I'll give you 5 minutes on that, and then we'll come back and talk together. We don't need a reporter because I can just stand here and listen to you and summarize at the end. This is a good point to intervene, because you were asking some good questions, because you were settling around that you might want to understand where students are employed when they graduate, and you might want to understand what the employers think they need to be successful in those jobs. But then the question is, how do you get that information? Where do you go to get that information?
Ask Google.
Well, you could ask Google, but I think I'm going to show you something that we have that can help you actually know that, and not just about students in general, but about SMU students.
When you mean we have, is that we SMU?
We SMU. We SMU. We have a tool. We have a tool for that. So just generally, I think AI, this is a place where AI can help you. So AI, we're going to talk about two tools. We're going to talk about ChatGPT, but we're also going to talk about, first and foremost, about SteppingBlocks. AI platforms can help you with this. They can help you identify career paths. They can help you see where students actually are employed. And SteppingBlocks, which is a tool the university owns, which any faculty member can have access to simply by asking my office for access to it. And also our students, there's a student platform that students have access to, which helps them see where our students have gone and how to map the path that they want. But we have a tool that can tell us. So SteppingBlocks has information about 100,000 or so SMU graduates going back a couple of decades. And you can go into it. It's the graduate outcomes module, and it will actually tell you, and what I'm going to show you is what I looked up. You can go in and you can look up, where did our Bachelor of Science in Chemistry students, where do they go? What kind of jobs do they have? Where are they employed? And you can pull that information. And so if you were in the approach that you would want to ask employers, this would tell you where they were going.
Which employers?
That's right. And you can see what kind of job roles they're in, so that you can kind of understand maybe what kinds of things your students are doing with their degrees when they leave. But beyond that, so you can see some of that here. So you can see here are the top companies where our Bachelor of Science in Chemistry students are employed. And here are the kinds of things that they are doing. So that kind of gives you a general idea, because you might be able to say, oh, what would a scientist need to know? What would a doctor need to know? What would a dentist need to know that we might be teaching in chemistry? Yes.
And you mentioned the SteppingBlocks. You can find SMU students in the past decade. So how how the system gather those data?
So it is using AI. Yes. So we got the question is, where does Stepping Blocks get its data about SMU students? It's a scraping tool. It's an AI scraping tool, and it is scraping information from federal databases, Bureau of Labor Statistics, Indeed, and other job search uh, companies, and LinkedIn. So it is scraping publicly available data about our students. It's correlated to our catalog. We fed our catalog and degree plans in it. So it's searching for those kinds of terms, and it's finding our students. And we have had some departments actually, because the data, if you have a certain level of access, is downloadable. So we've had some departments actually download the information in Stepping Blocks about their students. Michael Harris in Ed Policy and Leadership did this and compared it to what they knew about their students in the program, and they were able to validate the data. So it's fairly accurate. I'm not going to say it's 100% accurate, but it's fairly accurate. So, but beyond that information, another thing that Stepping Blocks can tell you is what are the skills that your students report that they are using in the jobs that they have. And if I were going to go about designing a program backwards, this is where I would go. I would look at the skills that they are telling us that they are using, at least for some of the outcomes. And then I would try to figure out which of those are probably coming or should be coming from our program. And that is where I would go to write the outcomes.
What are reported?
It is the frequency with which they are occurring and whether they're listed as a primary or secondary skill. You just have a screenshot, so we don't have the full amount. But there's a lot of data in there, and you can actually even pull like what are the career pathways that students use. There's a lot of information in there about what students are doing, how they got there, what their previous roles were. And so this is just a skills analysis about how frequently these terms are returned by your students in their current or previous roles. So, so you can see if we look up here, laboratory research, that is probably something they should be learning in their BS in chemistry.
Yes.
And it's a clear skill. It's the top skill that comes up. Board certification, we're probably not supposed to be teaching them that, so we could put that one away. Health informatics, we may not be directly teaching them that either. That might not be something they're getting in their BS in chemistry. They're certainly not using surgery, but research comes up again, research and development. But then we see something, analytical chemistry. That's apparently quite important also. Probably they should be learning that, at least a beginning level of that in their Bachelor of Science. Material science, that's probably something they should be getting in that Bachelor of Science in chemistry. Maybe chromatography. Again, I don't know anything about chemistry, so I don't know, but I can figure with the nothing that I know that probably material science, analytical chemistry, and laboratory research are relevant skills that we ought to probably be addressing in the Bachelor of Science in chemistry. So, yes.
And this is for the data, not just undergrad, graduate. Right?
This is for undergraduates. This is filtered by, because you can filter by, the question is this just data for all chemistry graduates from SMU, or is it degree level specific? So you can filter the data that you get in a lot of different ways. So this is filtered for students that completed the Bachelor of Science of Chemistry. This is, and they clearly have gone on, because we saw some surgeons and some doctors and some dentists, they've gone on to get maybe additional degrees since then. So you do have to do some thinking about that. Like I said, clearly we're not teaching them surgery in their Bachelor of Science in Chemistry. I hope not. So you do have to think about which of these skills might they have gotten from their bachelor's degree. But yeah, you can filter by degree level. So if I wanted to look at the master's in chemistry, the PhD in chemistry, I can do that. If I wanted to look at total chemistry graduates altogether, I can do that. So it's in there. Okay, I'm going to skip this because we just went over this, but probably I would say those 3 skills that we mentioned are probably the most relevant ones. And then we do want to bear in mind something you all said in your small group, that there might be other skills that are not chemistry specific, that are industry important, like the ability to communicate or work collaboratively, that kind of thing. So you have to bear that in mind, and they may not, those skills may not show up. Students may not put communication in their um, resumes and on LinkedIn when they're a surgeon or a doctor, but surely we hope they can communicate, right? And things like that. So we're gonna try, we're gonna walk through how we might use what Stepping Blocks gave us to write outcomes. And I told you ChatGPT can do a lot of things. I just like to show off the things that ChatGPT can do. So I said to ChatGPT, hey, ChatGPT, can you write me a slide, a PowerPoint slide that explains how you write program outcomes? And this is what it generated for me. Now, if I were just going to do it on my own, I might have tweaked it a little bit, but it did a pretty good job. It got SMART outcomes in there, which is something we talk about all the time to make sure your outcomes are specific, measurable, achievable, relevant, and time bound. And it explains what those are. And it also gives you the ABCD of writing outcomes, which is you have to consider audience, you consider the behavior that you're trying to encourage and measure, you consider the conditions under which you want students to be able to perform these things and the degree to which you want them to be able to perform it. So ChatGPT can do a lot. It can even help you with your PowerPoint presentations. And I did disclose that it was written by ChatGPT. It was actually written entirely by ChatGPT. Okay, so we are not going to use Stepping Blocks to write our program outcomes. We're going to use ChatGPT to write program learning outcomes. And ChatGPT is really good at this. Once you've identified your core competencies, you can go to you get those from Stepping Blocks. You can go to ChatGPT and you can have ChatGPT help you write or write for you if you're so inclined, the learning outcomes for your program. And the key with ChatGPT is to be very clear about what you're asking it to do. It's your prompt engineering matters a lot. So if I were to prompt ChatGPT for this particular task, I picked laboratory research and analytical chemistry, and I would be very specific. So this is the exact prompt I gave ChatGPT. I said, ChatGPT, for some reason, I always address it politely and thank it. Please write me a program level learning outcome for a BS in chemistry. So I'm very specific for each of the following skills: laboratory research and analytical chemistry. And then what you have on the other part of the slide is what ChatGPT gave me back. So for the first learning outcome, which is laboratory research, it gave me graduates will demonstrate proficiency in conducting independent laboratory research, including designing experiments, applying standard laboratory techniques, and interpreting experimental data to address complex chemical problems. Now, I don't know enough about chemistry to know if that needs a little tweaking, if that's level appropriate, but from a learning outcome, program learning outcome perspective, that looks pretty good to me. So for analytical chemistry, it says graduates will exhibit mastery in applying quantitative and qualitative analytical techniques to accurately measure and interpret chemical phenomena utilizing modern instrumentation and data analysis tools. And again, I don't know enough about chemistry to know. This is why you need an expert person working with ChatGPT to say, yes, that's at the appropriate level. Yes, that is something they're doing in the bachelor's degree, not something in the master's degree. But in terms of learning outcome, writing a program learning outcome, again, that looks pretty good to me. And if it's not at the right level, you can work with it to refine. You can say, ChatGPT, this is a little too advanced for a bachelor's program. Can you modify that outcome to bring it down a level to bachelor's degree? And it'll rewrite. And it tends to learn as you work with it. So any comments or questions about that?
I think seems like ChatGPT can be a very useful tool to initiate conversation with faculty and program. But like Dana mentioned, you still need to really kind of finalize and polish. For example, the second, the learning outcome for the analytical chemistry, we tend to like ask program when they write the program learning outcome, just identify one or a single outcome for a statement. So that way you can
Actually measure it.
yeah, then you can easily to report whether you complete your target or properly complete your target. So this one has,
Although if you used it like this, so the concern that was raised is, are there too many things going on in these learning outcomes? If you think about, and it's true, there should be a single statement, but if you think about the model, for example, that we use in general education, we have a broad learning outcome statement, but then we have the supporting skills. And I might not take this exactly as it is, but when I design the rubric, there are the specific skills to break it down into implied in that outcome the way it was written. But I think the broad point is we don't suggest relying totally on ChatGPT to write your program outcomes, because the program expertise is important. It's got to be vetted. And you need somebody with an expert eye looking at it and saying, is that level appropriate? Is that skill appropriate? And maybe refining it a little bit. But in terms of what it gives you as a starting point, it will save you a lot of time. It gets you going in the right direction really quickly. And I can't refine these because, as I said at the beginning, I don't know anything about chemistry. So I'm not in a position to refine them. Okay, so assuming I just worked with the outcomes as it gave it to us, but assuming you have the outcomes and you're happy with them, you can also ask ChatGPT to do the next step, help you do the next step, which is to design your assessments and your rubrics, to do the next stage of backward design, which is to figure out your evidence threshold and your way of gathering it. And so this is the prompt that I gave ChatGPT. I did this on the laboratory research outcomes. So I said, ChatGPT, please design an end of program assessment for BS in chemistry for the following learning outcome. And I gave it back the outcome that it gave me. And I'm not going to show you everything that it gave me, but it actually gave me back not just the assignment, it gave me the instructions for the assignment, step-by-step instructions for the assignment, and the rubric just from that prompt. Now, it knows I like to do this stuff, so it may have figured out that I was going to ask it to do it anyway, and it thought, I'll just save you some trouble and give it to you now. But it was interesting to me that without me prompting it, it gave me all of that. So what it gave us is, graduates will design and execute an independent laboratory research project addressing a complex chemical problem. The assessment will evaluate the student's ability to design an experiment that aligns with a specific research question or hypothesis, apply standard laboratory techniques to conduct the experiment, interpret experimental data, and connect findings to broader chemical principles. And as I said, it gave me step-by-step on what you would give the students and a rubric to go with that. And again, we wouldn't just take what it's giving us. You'd want somebody expert to reflect on it, but it will get you pretty far down the path and save you many hours.
That's what it's called. The human in the loop.
Yes.
The AI jargon of having somebody always check out the information that is coming up with.
Yeah, but I've heard some people say that, yeah, ChatGPT or the AI, generative AI, you need to treat them like a very basic internship.
Yeah.
You know, those interns come to work for you, so it will generate a lot of stuff for you, but as a human being or subject expert, you still need to do the modality, whether it be chat.
Yeah, so we're all in the room agreeing, and Addie wisely pointed out that she says this is called keeping the human in the loop, but you absolutely do. We're all agreeing. You need that expert. ChatGPT cannot replace us. We need our expertise involved in this, and we need to be looking at and evaluating and refining what it gives us. but there we go. And then I asked ChatGPT, now, if I were really going to do this, I'd probably feed it the catalog, the SMU catalog entries on chemistry, and I didn't do that. So it just made up course numbers. But I said to it, can you write me a curriculum map that would develop this skill of laboratory research across a Bachelor of Science program? And it made up some course numbers, but they do correspond to courses that we teach. And so it kind of begins to break it down for you about where are the courses, because chemistry sequences are fairly standardized because the American Chemical Society oversees many chemistry programs and kind of dictates programs. So it will tell you, and again, you'd want an expert to check this, but it will tell you where should this be introduced, where would it be developed, where would it be reinforced, where would it be mastered. It actually gave me, I didn't want to take up all the slides, but it gave me all 4 levels, years 1 through 4, and broke that down. And again, I don't think I would take what it gave me as gospel, but it gives, particularly faculty often struggle with this, it gives you a really good start and a model for how you do it. So very useful. Okay, well, we are actually way ahead of time. So we have lots of time for questions or comments. So anybody have questions or comments that we didn't already address?
Oh,
So you said that if people want access to stepping blocks, they need to contact your office. Could they just maybe put a ticket to the help desk or just email you directly?
You email Tristan Watkins in my office. Tristan Watkins. And we have a page. We have a career outcomes page on the Office of Institutional Planning and Effectiveness website. And there's a stepping blocks link there. And it tells you how to get access there if you need it. But you email what you email.
YouTube as a link under
Yeah.
the video.
What happens is you email Tristan. Tristan will generate a permission for the person asking. It generates an email that it sends to the person. The key thing is that link in the email will expire, I think, in like 48 hours. So you have to, don't ask for access unless you're ready to use it, because it will expire after 48 hours. But we give you access, and any faculty member who wants it or staff who wants it can have access to career outcomes. Now, there are different levels of access. So there is student identifiable data in the system. We don't give faculty that level of access, but we give you general, but your dean's offices have that level of access, and they can give it to you on request. So, yes.
Who has developed this system? Is this in-house made SMU software, or is this just some general thing available to everybody?
Yes, this is a pay-for platform. SteppingBlocks is its own company, because a lot of schools, career outcomes are becoming much, much more important than they ever were. And if anybody wants to know the whys and the wherefores and the things that the Department of Education is doing, I'll take them to lunch. But they're increasingly important. They're important for students and parents making decisions about where students should go to school. They're important for parents and students when they're calculating return on investment for the cost of education, because we're in a world where that's it's in question whether there is a sufficient return on investment. So they help us, if we have good data on our career outcomes, they help us tell the story about our values. So this is a platform that you can buy, and many, many other schools use this platform. So I became aware of it because they reached out to us, but all of the public universities in the state of Georgia, the state adopted this for them. UT Austin uses the system. So this is the system SMU bought. There are I think they were the first, but there are some other products now that are kind of imitators of this out there. And many institutions have adopted this. So it's a really, I think, powerful tool, and it's very easy to use, really intuitive. And as I said, it's got a lot of uses for us, but it's got a student facing side too. And it takes them from their interest inventory through their major to possible career paths, what additional skills and training they might need to do certain jobs that they may say they want. So it helps students too, and it gives students information about what the career paths have been of SMU students doing the things that they think they want to do.
Is there a cadence to program redesign that the university recommends to departments? So every, I don't know, 10, 15 years, they should be looking at a tool like this to then go through the steps and see how useful their programs may be to their students.
So there are two levels to what should be going on. Every year, every program is supposed to be engaging in program assessment using your outcomes and your program goals that you've established. And through that assessment process, you're supposed to be evaluating whether in fact students are learning what you think they're learning. And if they're performing at the level that you set as a target, you're supposed to move that target a little bit. And so through that process, there should be ongoing continuous evaluation of program and continuous improvement. But that's at a more incremental level than what we are talking about here. I would say SMU's kind of cadence for big rethinking of programs is probably driven by academic program reviews that happen every 7 to 10 years. When the departments that house the programs are supposed to be doing a deep dive and a self-study. And so that probably is a good kind of routine cadence to ask these questions. But there can be things that come up. Like if you suddenly see that your enrollments have a sustained drop that continues, that's probably should be a trigger to reflect on what's going on in your program. Or like in the case of French that I said before, we still had majors, but we observed that our students, there was misalignment between what our program was emphasizing and where our students were going. So that triggered us to think that we needed to stop and do that step. So on an incremental basis, it should be ongoing. These big overhauls, I would say the academic program review calendar should trigger it, but programs should always be attentive to signs of some other big shift in their program that indicate that there might be a need for this. And if you're in a program with licensure, that leads to licensure, I would say if the licensure requirements change, then that is something that should cause you to do this. So what the specific triggers are, I think are program specific, but certainly we want on an annual basis reflection on this and action on this on a smaller level than full program redesign, but at least every 7 to 10 years when you're doing your self-study for your APR, you should be really thinking through in this way. But that was a great question. Any other comments or questions?
Thank you very much.
Okay, well, I hope at the end of this session, everyone now knows about stepping blocks and knows how to use it to help backward design a program and knows how to use ChatGPT to help with that as well.